Okay, let's give you guys a problem to solve. So this is a 4 petaled rose, and in polar form, the formula to draw it is given by this. And the blue circle is of radius 1. It is of radius 1. So if you jump to Desmos, go to desmos.com and punch this in, it will draw you a 4 petaled rose. So if you change this number from 2 to 3, from 3 to 4, from 4 to 5, and so on. So play around with it. So that's how you draw it. So anyway, let's jump back to here. Show that this area here. Work out the area of one petal, and then times it by 4. It will give you the area of 4 petals. Show that the area is half the area of a circle. So this area here, here, and here is actually half the area of a unit circle. Remember, the unit circle is area pi. Anyway, show that this area here, 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 and here is half the area of the circle. So press pause and have a go. Okay, so to do this, let's try and understand what's going on first. So if you punch this in, if you just draw this graph here, r, the radius, and theta. So because of this 2, you're going to have a cycle. You're going to have 2 cycles. So normally your sine graph looks like this with 1 cycle. But because of this 2 here, you're going to have 2 cycles. 1, 2. What this is saying is that, well, don't forget, as you're drawing this petal, you're moving around like this from 0 to 2 pi. So this is 2 pi here, and then keep on moving, and then you're back to 2 pi. So you're moving around from 0 to 2 pi. But look what's happening as you move from 0 to 2 pi. As you're moving from 0 to 2 pi. Hang on, let's start again. So here you're moving around like this. So let's say when the angle is 0, you can see. When the angle is 0, you can see that the radius is 0, so it starts here. But as you're moving around like this, hang on. As you're moving around like this, let's say by the time you get to 45 degrees, which is pi over 4. Well, pi over 4, well, this is pi here, pi is here, pi over 2 is here, pi over 4 is actually here, 1. So by the time you get to pi over 4, the radius is actually right here. The radius is 1. That's why by the time you get to pi over 4, the radius is 1. And you can see that the radius is of length 1. That's why it's right here. And then beyond pi over 4, you're moving around like this. By the time you get to 90 degrees, which is pi over 2, by the time you get to pi over 2, you're here, and the radius is actually 0. That's why when you get to pi over 2, the radius is 0. So you can see that as you're moving around like this, the radius, as you're moving around like this, hang on, you can see that the radius is increasing, and by the time it gets to pi over 4, which is here, the radius is at its maximum of radius 1. So this is of length of radius 1, and then beyond pi over 4, you can see that the radius is decreasing. You can see that the radius is decreasing. You can see that the radius is decreasing, and then beyond 90 degrees, so you're moving around like this. Hang on. By the time you get to 90 degrees, you would have done 1 petal. So you've moved around like this. You would have done 1 petal. Beyond 90 degrees, so now you're here, 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 here. So let's say you're currently here. Okay, so when you are at an angle of hang on, let me think, so this angle here is hang on, let me think, pi over 4 is 45 degrees, and then times 3. So pi over 4 is 45 degrees times 3. 1, 2, 3. So this angle here is 3 pi over 4. So when you're at 3 pi over 4, when you're at 3 pi over 4, which is right here, 3 pi over 4, because this is, yeah, well, when you're at 3 pi over 4, the radius is actually -1. So when you're facing in this angle here, the radius is -1. The radius is -1. That means you're actually here, because this is This is a positive radius. A radius of -1 would be you moving in the other direction. So what's really weird is that the petal is actually moving like this, and then it moves around like this. It's kind of weird. Let me just illustrate this again. Hang on. You're moving around like this. By the time you get to 90 degrees, you would have done one petal. You would have done one petal. But as you go beyond 90 degrees, wait there, as you go beyond 90 degrees, the radius is actually negative. You're in this region here. The radius is negative. So by the time you get to 3 pi over 2, your radius is actually negative, so you're actually pointing in this direction. You're actually pointing this direction. So if you continue around, so back to here, when you're here, when you go beyond pi, the radius is positive. So when you're beyond pi, so when you're here, the radius is negative. So when you're here, when you are facing here, it actually correlates to this bit here. So the radius is 1. So it is a positive radius. So this is positive radius. This here is negative radius. Well, anyway, I hope you can follow what's going on. Maybe I explained it badly, but I hope you can see what's going on. But the petal is actually moving around as you're moving around like this. As you're moving around like this, the petal is actually moving around like this. It's moving around like this. It's drawing like this. If you really sit down, pause the video and think what's going on, it's actually moving around like this because of the nature of the radius. When you have a negative radius, it acts in a weird way. Well, anyway, I hope you can follow that. The area of one petal is given by this thing here, from 0 to pi over 2. Because when you're moving around like this, by the time you get to 90 degrees, you would have done one petal. So we are working out the area of one petal from 0 to pi over 2. And well, to work out the area, we would need to put this radius into here. So that would then become this. By the way, I'm expecting you to know this this formula by now. The area is given by this thing here. So you put oops, bear with me, sorry, bear with me. Okay, so we are currently here. We now need to put this thing into here. That will then give us this thing here. And whenever you want to integrate sine squared, you've got to think about this thing here. But notice that this angle here is always twice the size of this angle here. So let me just reiterate. This angle here is always twice the size of this angle here. But because you've got a 2 here, then what's over here must be twice the size of this. So if you have a 2 here, this would be twice the size, so it would be a 4. If you have a 3 here, this would be twice the size, which would be 6, and so on. But here we've got 2, so that would mean this would be twice the angle, so it would be 4 theta. Well, anyway, to integrate this, that will then take you to here. So now let's factor out the half. Let's factor out this half, and then this half is a constant, so take it out. That will then give you a quarter. So now this is slightly easier to integrate. So integrate this. Hang on. So integrate this. It will give you theta. Integrate this. It will give you this thing here. So now put this into here. That will then give you this. Put this into here. That will then give you this thing here. And then take away take away, put this into here, and then put this into here. That will then give you this. So this disappears. Sine of 2 pi. Sine of 2 pi. Sine of 2 pi is actually 0. So this block here is 0. So it just leaves you with this. So that will then give you. Hang on. That would give you. This times this would be pi over 8. So the area of 1 petal is actually pi over 8. Hang on. So the area of 1 petal is pi over 8. So 4 petals would be this thing here. And remember, the area of a unit circle is the whole area is pi r squared. The radius is 1. So the area of a unit circle is pi. So so you can see that 4 petals is half the area of a circle. Okay.